Hey, I'm Ryan from ngrok. Most people know us as the fastest way to get a local app on the internet. You open a terminal, run ngrok HTTP, and now your local dev environment or vibe-coded app has a stable URL. But ngrok is more than just tunnels to localhost. Here's how teams are using ngrok in ways you might not expect, such as connecting to internal services in customer networks. With ngrok, there's no need for VPNs or firewall changes. You get direct private connections from your cloud to only the specific services you need access to in the customer's environment, not their entire network. On the customer side, an endpoint's config file defines the services ngrok can reach. Each service defines its internal endpoint using the URL field, which is the address used to access it from your cloud environment. You can ignore the Kubernetes bindings here. It's an internal implementation detail, and there's no dependency on Kubernetes itself. ngrok is then installed and run as a system service, running in the background to keep connections alive, including after reboots. We can then confirm the endpoints were created from the agents page in the dashboard. In your cloud environment, the ngrok DCLI runs as a system service, designed specifically for managing connections to internal endpoints. It handles DNS resolution and authentication using mutual TLS and includes ngrok-CTL for management tasks. To test, I'll use the app-provided endpoint with TLS translating to HTTPS. And there's the response from my test app. That's ngrok private connectivity. Secure, direct connections between services in isolated networks, without the hassle of VPNs or firewall changes. The next use case I want to show you is preventing unprotected public tunnels. Public tunnels are essential for things like local webhook testing, but they can pose a security risk, which is why platform teams need control and visibility into who's using tunnels and why. So instead of exposing a public tunnel directly, developers use internal tunnels that can only receive authorized requests from the outside world. We call this the front door pattern. When a request comes in, a built-in ngrok OAuth provider, such as Google or GitHub, gets the user's email address. And if it's confirmed as a staff address, the request is forwarded to the right internal tunnel using the wildcard value, such as a developer's username. To set it up, the first step is to add the wildcard domain on the domains page. Then, from the endpoints and traffic policy page, a new public cloud endpoint is created, bound to the wildcard URL. The traffic policy steps are then added for triggering the OAuth flow, checking the received email address, and if not denied, forwarding the request to the internal endpoint in the form of HTTPS wildcardvalue.internal. Each request could also be logged to your observability platform as an audit trail. To test, a username is plugged into the wildcard portion of the URL. We're taken through the OAuth flow, but we've got a 3200 error. That's happening because there's no endpoint running on my machine yet. To create it, the ngrok HTTP command is run with the URL flag to set the internal URL. We'll try again, and we've got a different error, 8012. This means ngrok received the request on my machine, but there was no service to forward it to. These are the two most common errors you might run into, so I wanted to show you why they happen and how to fix them. With my test app now launched, the browser is refreshed, and this time the request goes through. This gives developers a best practice to follow, but to prevent public tunnels entirely by locking down the URLs they can bind to, you can create a service user for a developer, add a new auth token, then define the allowed URLs in the ACL rules field. That's the front door pattern. Developers get the public tunnels they need, while platform teams get control over access rules and full visibility into tunnel activity, either through the dashboard's traffic inspector, which provides a detailed snapshot of every request, or by exporting requests to their observability platform. The last use cases I want to cover are ngrok as a gateway for devices, APIs, and LLMs. ngrok is also used as a device gateway, providing secure access to software and devices in remote networks, such as internal point-of-sale systems or IoT sensors in warehouses and golf courses. You'd be surprised where ngrok ends up. Each device gets its own URL with traffic policy providing protection and routing. And instead of re-implementing the same rate-limiting, WAF rules, and JWT validation across every API request, you can centralize them using ngrok as an API gateway, acting as the first line of defense for all your API traffic, including DDoS protection. But ngrok isn't just a gateway for inbound traffic. Our new AI gateway lets you route, restrict, and manage requests to any cloud or self-hosted LLM through a single endpoint. The key difference between ngrok and other AI gateways is that you can directly route to self-hosted models in private networks using ngrok internal URLs, so no public LLM endpoint is needed. And that's ngrok. We started with localhost tunnels, but what ngrok provides today is a way to connect services across any network boundary, either directly through private connectivity or through a gateway that handles security, routing, and observability. I'm Ryan, and thanks for watching.